Hey everyone, in this video I want to show you how to make this improved version of my force field impact effect from 5 years ago. This time I have upgraded it a lot. So in this video you will learn how to make this cool looking force field effect with a bit more complex material than last time. Also you get to create this ground aura effect, and last time you could only have one impact, and if you had another one it would reset, but this time I have solved the issue. So this time you can have like infinite amount of impact and the last one won't reset. I will show you right now. So here you can see that you can have any number of impact and the last one won't reset like last time. Here you can only see 3 because of the time that I have given each wave. So if I increase the time of the wave, it will last longer. So if you have like 4 different guns firing at the force field, you will have 4 different effects at the same time. So that is one improvement. Another one is that if I press the E key, it will dissolve like this. And if I press E again, it will come up like this. So this is another improvement I have added, and there are even more improvements. So if I go into the instance, here you can see that I have some advanced colors here. So we can get these advanced colors by using a curve. So if I click this, I get this curve, and you can adjust this curve to get different colors. So if I just change the hue, you can see that the color changes. I can also change the individual colors here. So I can have more depth like this. And here, if I click this, I can change the gradient to something I have created before. So if I open this up, I can see all these gradients and I can select that and put that in like here. So if I just put this in, I get this and this. So you can create your own gradients and you can have different color combinations really easily. And here, if I change the alpha, I can just dissolve the thing like this. So if I just click on the pan opacity and if I disable that, it will look like this. So it won't really pan the noise anymore. And here, so if I change the opacity texture to like this purling noise, then I get something like this. So if I change the alpha here and change the opacity bias like this, you can see here that I'm getting a new effect. So if I change this to this tone texture, I get something like this, and I can have an effect like this, and I can change the edge width like this. So I get a new effect. I can change the color of the edges, and now if I click on pan opacity, it will pan it like this. And if I press play, here I have a new effect. And if I press E, it will dissolve like that. And if I press E again, it will come up and stay there like that. So you can control the opacity bias for that. And the alpha you can control through blueprint. So you can control the dissolving of the force field. And there are a lot of effects here. So here if I just get a sphere, if I bring it here and if I scale it up, you can see that the effect is aligning to the sphere like that. And here also you can see the lines adjusting to the sphere like that. So this effect has a lot of advanced things going for it. So if you want to download the entire project file, you can support me on my Patreon, and for $5 you can download the entire project file and also these 3 extra effects that I have created. So here you can see this kind of grid effect, and here you can see a prismatic effect, and here you can see like a blue flame effect. And here you can see the additional effects that are kind of variation on these 3 effects. So here you can have this glow effect. Here you can have this broken glass like effect. Here you can have this force shield effect like this one. And here there is another effect. And here also there's a really cool looking effect. So here these are all created from these effects. So if I just select the material, and here I can change the flame color and I can change the main color of this one. So I get a different effect like this. And here if I go to the main controls and pick pan opacity, if I just select this and go to the instance, and here I can change a lot of parameters, and here if I just pick pan opacity and if I change the bias like this, I can have a effect like this one. I can also change the opacity pan speed and also the tiling like this. And also if you support me on my Patreon, you also get these textures. So if I add this here, I get a very different effect from before, like these ones. So all of these have the impact effect and the bounce effect, etc. So if you support me on my Patreon for $5, you get these 4 effects and also this additional variation of effects. So this one, this one, this one, this one, and this one. And you can also create a limitless amount of new effects by mixing and matching different parameters and adding new textures to it. So please consider supporting me on my Patreon and downloading all of these files. So for $5, you get to download all these files and also the project files from my previous tutorials also. And if you're already my patron, thank you very much for supporting this channel and me. It means a lot to me. Thank you. Hey everyone, I wanted to take a moment to shout out my patron Ian Fish and his brother. Their team is making a new game. It's called Kingsmaker. I am pretty sure you probably have seen the insanely cool trailer of it on YouTube by now. This game is in your typical medieval game. In this game, you get to go to the medieval battlefield with a machine gun, a truck, and even crazier, an attack helicopter. And you get to mow down your enemies and build your own empire in this insanely cool looking sandbox game. This game can be played both in solo and in co-op mode. So if you are interested in this game, please go check out the trailer and also wishlist the game on Steam. The links will be in the description below. Thank you. And thank you Ian for your continued support. So to create this, right click, then go to material and click on it. And we can call this M underscore force field, then open it up. Now we want this to have a blend mode of translucent and a shading model of unlit. And we also need a two-sided material. So tick two-sided also. So now right click and create a material instance. Now go to add and get a sphere. So sphere. Now we can just go to the sphere here and change this to the editor sphere. This is much smoother than the original sphere. Now take this lock and scale it by 2. So it will scale that on all axes. Now we can bring this down. You can also use a half sphere if you want. And also you can go to modeling and then go to duplicate. So we don't accidentally edit our sphere. And now after that, we can just go to model and plane cut and we can just flip this. So we have a half sphere. If you want, you can also have that, but I'm going to have a sphere. And now I will just apply this and open the material up. And here first we can add the edge lines. For that we can either use distance field or depth fade. For this material, depth fade is enough. So we can add a depth fade. And if I just get an opacity, now if I just get a constant value of 1 and connect this to the opacity and connect this to the MUC color and click apply, you can see that the places where the sphere intersect with another mesh is black and the top is white. So if I just 1 minus this and connect this to the MC color, that part will be white. So if we give a value of 1, which is white to opacity, then only that part will be visible. I will just bring it here like this. So we get this part. Now if I change the distance to like 20 or something like that, then it will be a very small line. Now we can add it with other things to the opacity. And for the MSC color, we can get a blur and connect this to the alpha and connect this to the MSC color. Now get a vector parameter by pressing only V and clicking and name this color and connect this to the B. We can call this edge color and give it a really bright orange value like this. So if I click apply, you can see that we have an orange line like this. Now we need to take care of the rest of the stuff. So here if I give a value of 0 here and click apply, you can see that we get a really thin line and that's it. now we can bring in couple of textures we need for this. So first thing, we can go to the starter content and bring in the water texture, this water normal, and this X style texture, and bring that in. Now we also need to bring a noise texture. So for that, go here to the engine and type in T underscore noise, and there's a really cool noise texture here. So bring that in. Now we need to pan this noise texture around. So for that, get a texture coordinate by pressing only U and clicking, and get a multiply and get a scalar parameter by pressing and holding S and clicking, and name this noise tiling. So this will control the size of our texture or the tiling of the texture. And now we need to pan this texture around. For that, we need to get a panner. So for that, press and hold P and click and give a value of negative 0.4 here. And now we can get another lerp and connect this to the alpha here and connect this here. And we can also connect this to the add here. So now if I click save, I get an effect like this. Now here change the noise styling to 7. Now we need to distort this texture to get an effect like this. For that, we can get an add node and we can connect this here and connect this here, and we can just duplicate this one and connect this to the noise texture. Now change the pan speed to 0.2 and 47. Now if I try to connect this directly here, we will get an error because here this is a 2 vector. You can see that by this it has an X and Y, or here you can see that it only has a green and a red channel. So we can only give a green and red channel here. So in order to do that, we can get a mask. So mask, component mask, then only tick R and G and get a multiply. So we can control the intensity of this and change this value to 0.1, or you can connect a parameter here if you want to change it using the instance, and connect this to the add and click apply. So now we have this. So now here you can see that there's an opacity change in the center, and here also you can see that, and the edges. So in order to get that, we need to have a Fresnel. So go here and get a multiply and connect this between this and this, and now get a Fresnel node. So what this does is that it will create a gradient using the view vector. So if I just get a multiply and preview this, here you can see that if your camera is directly viewing the surface, it will be 0 or a low value, and if it is perpendicular to it, it will be a white value. So it's like a rim light. That's what Fresnel does. So if I just connect this to the multiply here and stop previewing, now here you can see that the center isn't really that visible now. So here you can give a value of 2 for exponent and 0.1 here. So we get a look like this. And for the multiply, we can give 3. So all these hard coded values that I am telling you is values that has worked for me, but you can feel free to change them. So you can experiment with this after you finish the tutorial. Now here we can add the grid to it. So in order to do that, just get a texture coordinate and a multiply and change this value to like 17. So it's barely visible. Now get a lerp and connect this here and connect this to the lerp here and connect the green channel to the alpha. So here if I open this up, you can see that the green channel has this X pattern in it. So here for the B here, we can give a value of 0. So it will be darker. So we get that dark X effect like this. You can also see the dark X effect here. Now we need to add some dots to this. So for that, get a radial gradient and get a parameter. Now get a texture coordinate. Now here get a multiply and change this value to like 140 and connect this to the UV here and just round this. And if I just preview this, nothing will happen. But if I change this value to like 1, you can see a circle. If I change this to 2, the circle will be here, but we need to have the entire mesh surface filled with circles. So in order to have that, we can use a node called frac. So what a frac does is that it will just output the decimal values. So we can have a repeated value if it goes above 1. So if I just connect this here and connect this to the UV, you can get 4 different ones. And if I change this to 140, you can have the entire cube filled with the circles. I will change this value to like 120 or something like that. Now get an add here and multiply this and this together. So now we get an effect like this and connect this to the add. And now we can multiply this with the original alpha like this and click apply. So this gives an effect like this one. So I will change this value to like 50. Sorry, I made a mistake here. We are supposed to add this together. Now we get a look like this. We can barely see the circles, but that's the look we want. So here you can see that the faded circles. Now we just need to duplicate this part and paste it here and connect this here. Now we can multiply the Fresnel with this one and connect the red channel to the multiply. So this is to give some additional depth to it. Now we can change the tiling here. Just delete this and change this to 3 and change this to -1 and change this to -0.1. So this will make it a bit more darker. Now click apply. Now we need to give color to this. So in order to do that, we can create a curve. So if I just go here and type in curve, so we get this curve atlas row parameter. But right now we cannot add any curves to it because we don't really have an atlas. So now we can create an atlas. So for that, go here and go to miscellaneous and go to curve atlas, and I will call this CAT and force field. Then open it up. So it has a texture width and a texture height. So we don't really need this much height. So untick the square resolution and change this to 2, and we can add 2 gradients. So this is all what we need. We can also decrease the texture width if you want. You can change this to 128, but I will just leave it at 156. So we get a really high res gradient, but we don't really need that, but it's okay for now. And now we can go to miscellaneous again and go to curve, and we can go to curve and we can add a linear color and select, and I will call this CB force field. Then open it up, and here you can click this and give an orange color like this, and you can go here and normalize this, and you can click this again and give a dark color. So we get a orange color and a dark color, and click here again and click here, and we can give it a red color. So let's see what happens. So now if I go back to the material and if I change this to color curve, and here I can just connect this color curve, and here I can just connect the red channel to the color curve and connect this to the lerp here. So now we have an error because we haven't provided the atlas or the curve. So for the atlas we can go for CAT force field, and this curve we haven't added anything. So we can go to the atlas here and we can add a curve. So we can add this one, and now we can select that here. So now we have given the color to the curve and we have this cool effect. Now if I open the curve, I can adjust the colors. So here you can see that the white portion has this really bright orange color. So if I move this closer and move the black one closer and delete this, the black will be black and the really bright portions will have the red color. So if I move this around like this, and if I add black here or a red and change that to black, and if I get a green here, you can see that the really bright portions have this red color like that, and the other values that are between here, it is going from 0 to 1. So the values between 0 and 0.5 is mapped to green, and the values that are at 1 and before this part is white. So that's how we are mapping the color to the gradient. So if I just connect the red channel to the lerp, here you can see that there are different values. So some places are very bright and some places are very dark. So the darker the place is, the value is closer to 0, and the brighter the place is, the value there is closer to 1. So that's how we are mapping this curve to the gradient here. So if I just connect it, we get an effect like this. And here you can just adjust the hue to get a really cool effect like this one. So if I go here, I get something like this. Now let's recreate this curve. So I'm just going to recreate this curve here so we get the exact same effect. So if I look here, the one value has this really bright orange color. So R is 200 and G is like 20. So we can give that there. And I will just reset the hue. And here we have a dark value here. And this value is like a dark red. So let's get that. And this value is like a pink color. So let's get the pink color. And then between that and the black, we have this really bright orange color. So click here and get that orange color. And then we have these two darker colors closer together like this. And now we get a color like this. Now we need to do the rest of the adjustment in the material. So to get the glow effect. So here, in order to get the glow at the edges, we need to multiply this curve by this Fresnel, but we need to power this by 6 first. So it will be really sharp around the edges, and connect this here. And now we can multiply this with 100. So it will be really bright around the edges. So we get a look like this. So if I just press apply, we get something like that. Now we need to get an add node and get a multiply, and now multiply this with this one. I will just move it back, multiply these alphas before the depth fade with this texture, and connect this to the add and connect this to the blur. So we get a unique look like this. So if I click apply, now we need to bring it up and get a lerp and connect this here again, and connect this edge color to B and connect this to the A of the lerp, and now connect this to the A again. So here this is the edge line, and we need to individually control the strength of the edge line. So here it is this line, and we need to control the brightness independently. So in order to do that, we can get to multiply and connect this to the B here and get a scalar parameter, and we can call this edge boost, and this can have a value of 50. So it will be really bright. And now for the alpha of the lerp, we can bring in the radial gradient circles we have created. So just bring that in. So I think a better way to bring that in here without all this mess will be just to create a named reroute node. So just type in named, and we can call this circle pattern, and now save this, and we can just disconnect the alpha and type in circle pattern. So now we have that also. Now here, this is obviously too much. We don't really want this much circle patterns. So we need to make a thin line that goes up and down. So the circles will be only visible in those areas. So now here, in order to get the thin lines, just connect this to the B here. And now get a linear gradient. And now get a multiply. And if I preview this, you can see a gradient like this. And if you want to have multiple lines like before, we can use a frac. And if I change this to like 6, and if I preview this, you can see that I have multiple lines. And here, if I just subtract this and then saturate and then round this, I can control the size of these lines. So here you can see that the lines have a gradient. And here if I subtract 0.4, then it will only have 0.1 after the round. So this saturate here is just to clamp the value between 0 and 1. We don't really want this to go to -1. So here there are values that are 0 or like 0.3, and if we subtract 0.4 from it, it will go to negative. We don't really want that. So we are just clamping that between 0 and 1. And here, what this round does is that if the value is below 0.5, it will round that to 0. And if it is above 0.5, it will round that to 1. So if I just preview this, you can see that I get a really clean line. And if I change this to 0.59, then it will be really small. And if I subtract 0.5 from it, it will be black because there is no width for the line anymore. And if I change this to 3, you can see that we have more lines because we are subtracting 0.3 from 1. So you get the rest of the gradient. And if I subtract 0.5 from 1, you will only get 0.5. And if you round that, you don't really get to see anything. But if I round 0.45, you can see a really thin line. So set that to 0.4. Now just stop previewing and multiply this with this one and click apply. So here we need to connect this here before all of this. Now click apply, and this value we can change the edge boost to 10. Now here we can distort this line a bit. So if I just start previewing this, and if I go to the normal, and if I get an add node and connect this here and get a UV coordinate, and now if I just connect this to the UV of the linear gradient, you can see it is very distorted now. So if I click apply, so we get the same effect we have here. Now we can go into the gradient and we can play around with these values. So I just move it here. So here one more thing we can do is that we can change the exponent to like 0.1 here and click apply. So we have an effect like this. It's similar to that one. Now we can go to the curve, and here we can change this to like black, like this. So now we have the effect we want. I made another mistake here. We are supposed to connect this color curve to the multiply in order to get the look like this one that I have created. So if I just connect that here and click apply and change the exponent to 2 back again and click apply. And now if I just open the curve and select all of this and click the auto curve here. So now we have that look. Now adjust these values like this. I'll just delete this and delete this and add a black color here and add another black color. So now you can adjust these values to get the look you want. Okay, I think this is what I want. Now just bring up the sphere a bit. Now we will create the alpha effects. So for that, we can go back to the material. And here I will just go to clean graph and clean up. So everything we don't need is gone. And I will just tidy things up a bit. Now we need to create an alpha effect. So for that, I'm just going to double click here and click here. So we get this rear out nodes, and here I will just copy this texture and bring that in here. And I will just connect this to the opacity and connect a constant value of 1 or 10 to the emissive. So here you can see that the white values are visible and the darker values are invisible. And if the values are lower, like gray or something like that, it is transparent. So that's how opacity works. If the value is 0, it will be completely invisible. And if the value is 1, it will be fully visible. And anything in between will be transparent. So we can use this property to have our dissolve effect. So for that, we can just subtract this by an alpha. So I will just create a scalar parameter and I will call this alpha, and I will connect this here to B and connect this to the opacity. Now if I change this value, before that I will just set the slider max to 1. Now if I change this, you can see that it is eating this away. And if I reduce this, you can see that it is showing. But at 0, it is still like this. But what if at 0 we want this to be fully visible, and at 1 we want this to be fully invisible? So in order to do that, we can multiply this value by 2. So at 0, the value will be 0, and at 1, the value will be 2. Now if you subtract 1 from this, at 0, it will be negative 1, 2, it will be 1. So here if I change this value to like negative 1, you can see that it is fully visible. And if I change this value to like 2, fully invisible. Here we are just remapping the -1 to 2 by just multiplying it by 2 and subtracting it by 1. So if I connect this here and change this value to like 0, now it is fully visible like it was -1. And if it is 1, it is fully invisible like it was 2. So that's all what we have done here. And now if I just set this value to like 0.5 and go here, you can see the cylinder like this. So if you want this gradient to go from top to bottom, we can do a linear gradient. And if I just multiply this with this one, and if I just increase the gradient, you can see that the top is getting cut off faster than the bottom. So if you want the opposite of the effect, you can just 1 minus this. Now we can have a UV coordinate and get a multiply for tiling, and we can call this opacity tiling. And I will default this to 1 and connect this here and connect this here. So now if I change this value to like 0.5, you can see it is getting visible and visible like this. But here we need to have an edge line. So if I go into this one, and if I just press play, and if I press E key, you can see that there's an edge line to the dissolve. We need to have that. So in order to have an edge line instead of this white color, there are many ways to do it. In this tutorial, I'm just going to show you a way using curves, because this tutorial is mostly about curves. So I'm just going to use curves to get this center line. So in order to do that, I'm just going to duplicate this, and I will call this alpha, and I can add this to the atlas. Here we can just delete all of these, and technically you can just use the alpha channel for this, but in order to show you what is happening, I'm just going to use the color channels. So I'm just going to click here and click here, and I will set this value to like black, and I will click here and here and set this value to like black also, and click here and set this value to like 1. So here at 0.5 of the gradient, we will get a white color, and before that we will get black, and after that we will get black. So what happens if I go here and I will just duplicate this and change the name to alpha curve. So here I'm just going to get a curve, and I will call this alpha curve, and change the atlas to the one we created, and change the curve to the alpha. And if I just connect this to the curve and connect the red channel to opacity, and now if I just change the, so here nothing is really visible, so I will just connect this to the emissive and this to the opacity. And now if I just change the alpha, you can see that the edges are white. And if I change this to like here like this, you can see that it is fatter now. So here I can change the size of the edge using this. So if I go here, you can see the instance, and if I change the alpha here, you can see how it is changing. Don't mind this artifact, this is because of the translucency, and it won't really bother us later. So here you can see that the alpha is thicker. So if I go here and bring it like this, you can see that more of it is visible. and less of this is visible like this. So here we want this to be closer here and this to be closer to zero 0.5, and this should be closer again, and this should be a bit closer. And here we can just go to normalize and select this and go here to the constant interpolation, so we get this square. So it is really sharp here, and here we have this gradient. So now when I move this, you can see that we have an edge color like this. So this is the same edge color that we are going to use. So now I'm just going to connect this to the opacity and connect this to the emissive and click apply. So now if I move this around, you can see that we are having our edge color like this. And here we don't really have to invert the alpha. Click apply. Now if I just do this, you can see that it is dissolving to the bottom like this. And you can change the opacity tiling, so it is more visible now. You can also go here and convert this to a parameter, and we can call this opacity texture, and now we get something like this. So in order to control the size of this, we can either go to the curve or we can just power this. So get a power and now get a scalar parameter and call this opacity power. Now if I change the opacity power, you can change the size like that. So this is exactly what we want. So now in order to connect both of these effects together, remember here we have these edges, and outside the edges we need to have our force field effect, and inside it we don't really want anything because we are going to dissolve that in. So outside it we need to have the force field. So in order to get that, we need to subtract this part from the curve. So we will just ignore the curve and leave the rest of the gradient intact because we are giving the edge color to the edges, and the rest of the part we want. And then we can round it. We are rounding this because we don't really want any transparency depending on the value of this texture. We just need to have one solid color like this. Then we can multiply the solid color with our original opacity. So this lighter values won't affect our original colors because it is either fully visible or fully invisible. Now we can just add this back together to the opacity. And now for the emissive color, we can get a lerp, and this edge color should be at this white values. So we can connect this to the alpha, and if the value is 1, then the B output is taken. So if you want the at the edge, we can connect this to the B and connect this to the MC color, and here we can connect this here and click apply. And now if I increase the alpha, you can see that it is visible like that, and you can reduce the opacity power and increase the opacity power a lot. We can also use a blur texture. So if I go to the engine and type in blur, so it's a low res blur texture, and this is really nice. So if I just add that, I get an effect like this. So I will just set the power to 2. And now these issues are because of the curve. So here we are supposed to connect the power after the curve. So that was the issue. So just connect that like that. Okay, now it's working really well. Now we can also increase the opacity tiling like this. Now if you want this to have that panning effect, we can go to the force field and get a panner, and now give a value of 0.1 and connect this here and click apply. And now if you want to increase the speed, we can go here and change this value to like 2 or something like that and click apply. And now we can change the tiling and increase the power or decrease it. We can also go to the curve here and move it closer and closer and move this closer too, and increase the tiling again. This alpha we are going to control using the blueprint, but if you want to have an effect like this all the time without the blueprint changing it, we can create an alpha bias. So we can go here and go to alpha here and get a multiply and duplicate this and call this alpha bias and connect this here. Now go here and 1 minus this. So at 1 all of this will be fully visible, and if I reduce this it will stay here. Now we can control this from 0 to 1, but it will also stay at the same position without going anywhere. Now we need to control the alpha using a blueprint, and for that right click, then blueprint class, actor, pp force field, then open it up. Now add a sphere and change the static mesh to editor sphere, this editor sphere. Now for the material, we can add the force field material we created. Now I will just move this away and bring in our blueprint. Now I will scale it a little bit like that by 2. Now we can go to the event graph, and here we can drag the sphere in and type in timeline, and we can call this animate alpha, then drag from here and type in scalar parameter value and connect this to the update. And for the parameter name, this is the alpha we created here, alpha. So the parameter name is alpha. Now open up the timeline. Now add a track and add a flow track, and I will call this track alpha. Then shift click here and set this to 0 and 0. Now shift click here and set the time to 5, since the maximum length is 5 and the value here to 1. Now we can just normalize this, and now we can connect this to the parameter value, and here we can create a custom event, and now here we can call this show force field and connect this to play. Now create another one and call this hide force field and connect this to reverse, or you can connect this to play from start and reverse from end. Play and reverse it back and forth. You can connect this to play from start and reverse from end. If you do that every time you call the event show force field, it will start from 0 to 1 and from reverse, and if you call hide, it will go from 1 to 0. But if you connect this to play, if the timeline is at 0.5, then it will play from 0.5 to 1, and if it is at 0.2, it will play from 0.2 to 1. And here if the hide force field is called at 0.5, when it is going up, it will go from 0.5 to 0. So this reverse end and play from start just reset and start from 0 or 1. That is the difference. Now here for begin play, we can just call show force field, and after finished we can call hide force field. So we can just test this out. So now if I just press play, you can see that it is coming up. Let's go down like that. So if I just press play again, you can see that it is coming up and going down. So that part is working. So if you want to activate this using blueprint, you can just call this function. You can just get a reference to this force field and search for this function and call this. So it will start showing, and if you call hide, it will hide the force field. So that's it for showing and hiding the force field. Now we can create the hit reaction like this. First we will create the bounce, then we create the particle system. So for the bounce, go to the material and we need to go to world position offset. Now here we can get a vertex normal and we can get a multiply and now get a scalar called bounce normal, then connect this to the multiply. So what this vertex node does is that if I start previewing this, you can see that it is just a bunch of direction where the vertex is pointing on the sphere. So if it is pointing up, it will have a blue color, and here it is pointing a bit to the right also. So it has a combination of blue and red, so that's a pink color. So this vertex normal just points to the direction of the vertex. If I just connect this to the world position, and if I increase the bounce normal like 100 or something like that, you can see that. And now if I just stop previewing this, you can see that it is really big. And if I set this to -2 or 20, you can see that it's smaller. So at 20 it is bigger, and at 0 nothing is affecting it. So by scaling it this way, we can scale it uniformly. If I just scale it using the scalar value, then there won't be any direction. So if I just change this value, it will move this way because we are not specifying the direction. So just think of this as a unit vector that points to the direction of each vertexes. So we can scale it uniformly. If I just do this, it will just move like that. So if I just get a 3 vector and connect this to the world position offset, and if I change the C value to 100, you can see that it is going up. So if I set this to 0 and set this to 10, Y and 100, you can see that it went right. So basically here we are giving a 3 vector, but it is just pointing along the vertexes. So just connect that to the world position offset. And here we can set the bounce value to like 100. Now we can get a lerp and connect this to B and get a new scalar parameter. And we can call this bounce alpha. So with this we can scale the offset. So at 0 it is like this, and at 1 it will be this value. And we can control this in the blueprint to get the bounce effect. Now we need to pan a noise around this so we can get a nice bouncing effect. So for that we can get a multiply. Here we can also use a multiply instead of the lerp. Now for the texture, we can go to the engine content and type in wind and just filter this by texture by going here and clicking texture like that. And we can get the wind turbulence texture and bring that in and connect the RGB value to multiply and connect this to the B. Now get a texture coordinate and a panner so we can pan the texture around. Now set the speed to 0.3 and 0.3. So it just moves around like this. Now set the bounce alpha to 0. So it looks normal. Now go to the force field blueprint. I will just move this down a bit. Now go to the sphere and make sure that blow called dynamics is enabled. You can also create your custom trace channel or collision preset by going into the project settings, but I'm not going to do that because this is already a really long tutorial. So just set that to block all dynamic, then go to event graph and select the sphere and go to on component hit, and now drag and type in print string and connect the hit component. And now if I press play and get the gun, and if I just hit, you can see that what I am hitting. So here I will just break this so it is always visible, and also break this so it won't blend in, so it will make it easier to test. So here if I connect the other actor, so if I just press play and get the gun and hit it, you can see that I am hitting the force field using my first person projectile. So that projectile is in the first person blueprint, and this one first person projectile, I have just modified it like this, but nothing changes. You can use this. And now once we are hitting it, we can just destroy the projectile. So just connect this to destroy other actor. Then we can create a timeline and we can call this bounce. And here we can play this from start. And now we can go to the bounce and set the track length to 1 and get a float. and we can call this bounce alpha and go back, and here we can drag on the sphere again and type in set scalar parameter value, and this time the parameter value is bounce alpha. So this is the value we are going to modify, this bounce alpha, and now every time we hit this timeline will play and this bounce occurs. Now open the timeline and add 0 here and 1 for time and 1 for value. Now if I just press play and hit the thing, you can see the bounce effect, but it is really slow. So I'm just going to move it back, and here I will click on the middle portion, set this value to 1 and set the last value to 0 because we want to go up and then down. Now we can make it a bit smoother by selecting it all and adding an auto and shift click here and bring it down a bit and add another key and bring it up and add another key and bring it down and add another and bring it up. So we get an elastic effect like this. You can also create an elastic effect like this using the curve editor, but I'm just going to use this. And now we can go to the event graph and increase the speed a bit. So we can go to event begin play. Just delete all of this. We don't really need that. Now go to component and select the bounce. So we can name this TL bounce for timeline. And now set play rate. So this will increase the play rate to whatever value we give here. So if you give a value less than 1, it will be slower, and at 1 it will be the same 1 second duration we gave here. And if I set this to 20, it will be really fast. So here we can set this to 4, and now let's see. Okay, now it's really fast. So this is what we want. Now we will create the impact effects. So first we will create the sparks, then we will create the rings. So in order to create the sparks, right click, then go to Niagara system, and we can click next, then go to fountains and add and click finish, and we can call this NS impact, then open it up. So here you can see that it already has a fountain effect. So we are just going to modify this a little bit. So here we just want this to happen once. So just untick spawn rate and go to emitter state and set loop behavior to once and set the duration to 1. And now go to the update, click add, then select spawn instantaneous, and now set the value to like 40. And now go to initialize particle and set the lifetime to 0.4 and 0.6. So it happens faster. Now go to the add velocity and here set the cone axis to -1, and I will show you why this matters later in the blueprint, and just zero out the z value. Now we can go to the initialize particle and set the color to a bright orange color like this. Now we can go to sprite render and set the alignment mode to velocity aligned, so it will align to the velocity. And we can go to the particle update and type in scale by speed. So scale sprite size by speed. So we can scale it in the direction of the velocity. Now set the value to like 0.75 and 3 and 1.2 and 3.3. Now go to initialize particle again and set this uniform sprite size min to 2 and max to like 5. And one more thing we have to do is that we have to go to the local space and tick this. So it will spawn from the emitter location itself and won't change that location. So we want to spawn it from the embed location itself. Now we can duplicate this and we can call this curved. So we want a curved particle also. So here we want this to move in a curved direction around the sphere. So in order to do that, we can go to add velocity. And here for the cone angle, we can give a value of 180, and the inner cone, we can give a value of 170. So you can do spawn like this. Now we can disable the gravity and it spawn like this. And we can decrease the lifetime to 0.2 and 0.3. So it will be super fast, maybe 0.5. And we can increase the spawn count to like 200 or something like that. maybe 120. Okay, that's what we want. Now go back to the blueprint, and here after the impact, we can drag this like that. We can drag this here and type in spawn emitter at location, and we can break the hit and get our impact, and now get the location and connect that to the location. And for the, I made a mistake here, we need to type in spawn system at location. So this emitter at location is for the cascade particles and the system is for the Niagara. So just add the impact and connect this here and connect this to the play, connect the location to the location. And for the rotation, we can get to impact normal and type in rot from X and connect this to the rotation. So this is why we have added -1 here for the X. So it will face the opposite direction from the impact. So if I press play, so now you can see it is spawning the way we want from the direction of the impact, from the surface of the sphere like that. No matter where we impact it or from what angle, it will come out from the surface of the sphere. So here, connect this to the play from start. So that's why we didn't really see the bounce. So now if I press play, now you can see the bounce like that. Now to create the impact rings, select this sphere and we can go to the modeling and we can go to X form and duplicate this and click accept. So we duplicate the mesh. Now we can just set some other material here like this M floor so we can see it. And now go to model and go to plane cut, and here flip the plane like this and move it up like this, like about here. So we are just cutting this sphere and click accept. So we have a new mesh like this one. Now select that and go to X form and go to edit pivot and click top and bring it up a bit like this and click apply. Now we need to create the material for this. So right click M underscore circle, then open it up, and here we can set the shading model to unlit and the blend mode to translucent and get a radial gradient and connect this to the opacity and get a particle color. And now multiply that with the alpha and connect this to opacity, and also multiply this with the RGB and connect this to the MC color and click apply. Now if I just apply this, you can see that it isn't really showing up. So we need to fix that. For that, we can go to the modeling tools and go to mesh and UV and go to auto UV. So now it's looking really nice. So click accept. So now it's showing up. Now we need to make this into a ring. So for that, we can get a time node and a multiply node and connect this here and get an add node and connect this here. And now get a multiply node and get a frac node. So if I change the value here, we can get 3 rings like this, like before. And this time will just move the values around. So it will be animated like this. So this is what we want. Now we can just subtract maybe like 0.2 from it. And if we just round this, we can get rings like this. And if I connect this here, we get this effect. Now we need to fix this too. For that, we can 1 minus this and get a multiply and multiply this with the 1 minus of this. So we get this donut like shape. We can multiply this with this one and now with the round. So it's not visible. So just connect this to the round and multiply it like this and just seal this. So we will get a nice bright lines like this one, and maybe just connect this to the B here. So we can fade it out faster. Now click apply and save. So this is what we want. Maybe here we can also reduce the radius to 0.4. So this is what we want. Now we can go to the impact, and here we can add an emitter and single looping particle, and here go to the sprite renderer, then untick this, then add a new renderer and get the mesh renderer. And now for the mesh, we can select this mesh and select that and add that here. And for the material, we can enable material override. This will replace the material of the static mesh and add an array element. And for this material, we can add the circle material we created. So just add that like that. Now if I just play it from here, you can see that it is not oriented in the way of the impact. So we can fix that by going into the properties and clicking local space. And here we need to rotate this a bit. So we can go to add, we can go to particle spawn and type in mesh orientation, initial mesh orientation. Then here set this to system and click rotation and set this to 0.75. So now it is rotated towards the system like that. And now if I press play and fire, you can see that it is sticking to the sphere like that. So this is what we want. We can also go into the mesh and we can edit the pivot. So we can control where it appears by editing the pivot. So if I drag this down a bit, and now if I just fire, you can see that it is on top of the sphere like that. And if I go to pivot and click top and push it up a bit like that, then it will be inside the sphere like that. Now we need to add some fading to the rings. So go to the impact effect, then go to emitter state and change this to self and loop behavior to once and duration to 1 second, and go to initialize particle and reset this value, and now set this to 0.5. Now here we can type in scale color, and for the color here we can go to initialize particle and go to color mode and now click direct set and set this to the orange color like this. Now go to the scale color and here we are going to untick the scale RGB. We are just going to scale the alpha. Now type in curve. So we can scale this using a curve, and now click this one. So it will go from 0 to 1. We need to click this one. So it will go from 1 to 0 like that. And now we can go to particle update and type in scale, mesh, size. And here for the scale factor, we can type in float and vector from float. And here we can type in curve like before. And now click this one. So it will just ease in. So it will go from 0 to 1 like that. Go to initialize particle and go to mesh scale mode and set this to uniform and set this to 1. Now it should work. So if I press play. So now we have ring effect also. And you can obviously adjust the parameters to get a different effect. Now if you want, you can also add some collision to your fountain particle and increase their lifespan a little bit. And you can also change this to GPU particle, both the fountain and curved if you want. So you can spawn a lot of it. Now if I just press like this, you can see that it is bouncy. Now let's create the ground aura. So for that, right click, then material, m_ground, then open it up. We need this to be a decal, so we can project it onto the ground. We can go to material domain and click defer decal and change the blend mode to translucent. So we get this. Now we can go here to our main material and copy these parts till the curve and paste that in. Now here connect this to the MC color and now get a radial gradient and get a multiply, set this value to like 0.8 and get a UV coordinate and add this to the radial gradient, and here just delete this and get a rotator and connect that to the rotator and connect it like this. And here instead of the panel we can also get a rotator and connect it here, and here the value we can give a negative 0.25 for this one, so we get an effect like this. Now here we can multiply this with 3 and get an add node and connect a time to it like before. This time instead of a frac we can use a sine because that will give a smoother result. And here since the sine function goes from -1 to 1, we can just normalize this to 0 and 1 by adding 1 to it. So -1 will be 0 and 1 will be 2, and get a multiply and multiply this by 0.5. So 0 will be 0 and 2 will be 1. So we just remap sign from -1 to 1 to 0 to 1. And here, like before, we can get a multiply and 1 minus this and connect this here and connect this here. So we get a donut looking effect and get another multiply and give a value 0.5. So we can bring the value up a bit, and here we can multiply this with this one. And now if I preview this, you can see that it is very noisy. So in order to fix that, we can make our noise texture a bit blurry. So select that, and here go to the MIP value and select relative to compute MIP and change the value to like 4. So it will be blurrier because the texture is smaller now. And now we need to get our grid texture. So this grid texture, we can just copy that and paste it and set the tiling value to like 4. Now we can multiply this with the original gradient, and here we will multiply this with the green channel. And if I preview this, we get a look like this. Now add both of them together and connect that to the opacity. So now we get a look like this. And here we can also add this one with this one, saturate it and connect this to the curve. And here we can control the curve color by getting a lerp and connecting it to the alpha. And so if I preview this, we get something like this. Now if I set the value here to 1 and here to 0.8 and stop previewing, we get a look like this. So we can adjust these values to get different colors here like that. So click apply. Now if I just create an instance of this and bring it into the world, you can see that it looks like this. So if I bring it here, you can see that there is some intersection effects happening here, and we don't really want that. So we need to mask out the perpendicular planes to the surface. So in order to do that, it is really easy. So here, if I get a scene texture node, we can get a world normal from this. So go to here and get a world normal. So here it will output the normal of the world. So if it is a really flat surface, the C value or the B value will be 1, and if it is perpendicular to the surface, it will be 0, since the B here will be 0. So you can use that to mask out the perpendicular plane. So get a mask and only tick the B, and here we need to make it absolute because we also need to mask out the negative value. We also need to mask out the negative 1 for the B. And now if we just multiply these together and click apply, so now you can see that it is masked out. We don't really have the ugly effect that we had before. We can also do one more thing. We can go to the radius and set that to 0.4. Now click apply. That's a bit smaller. Now we need to create a Niagara particle system for this. So Niagara system, then click next, then click single looping particle and click add and finish. And I will call this NS ground, then open it up. And now go to sprite render and tick this, then type in decal render. And for the decal, we can add the instance we created and bring that in. So it's really small. So let's fix that. So in order to change the scale of the decal, if I just come here and type in scale, you don't really see scale decal. So in order to do that, we can go to the particle attribute and type in decal and get the decal size. And now drag that into the particle spawn. And here we can give a value of 200 for X and 650 and 650 for Y and Z. So it looks like this. So now if I open the blueprint and I can drag in our decal. So now we can see the decal here. And here if I just get a sphere, so if I bring the sphere, you can see that the decal is rendering on top of the sphere. So in order to prevent that, we can click that and type in decal and receive decal and untick that. So if you have something you don't really want the decal to be drawing on, you can do that. And now if I just bring this back like this, you can see that it is not even drawing on the flat surface. So that's what we want. So now if I just press play and get the gun, and now I can hit the force field and get the impact effect like this. You can also adjust the size of the decal, etc. So I think that's it for the tutorial, guys. Thank you very much for watching. And if you want to download the project file, you can support me on my Patreon. Thank you.